So this is a video on 7.2 using the sum and difference identities. Originally in 6.3 we had the identity of sine squared theta plus cosine squared theta equals 1. We have other identities that are similar to this that we're going to use for 7.2, and we have 2 for cosine and 2 for sine. Let's look at them. The first one is cosine of alpha minus beta, or I would always say just A minus B, and it's where you have cosine times cosine, so alpha and beta, plus sine alpha and sine beta. The second one for cosine is cosine of alpha plus beta, and it's written as cosine alpha times cosine beta minus sine alpha times sine beta. But for sine, we have the opposite of that, so let's draw that out. So sine is a little bit different. Sine is alpha minus beta, where sine alpha times cosine beta is subtracted by cosine alpha and sine beta. And the other one is sine plus, so alpha plus beta. We have sine alpha times cosine beta plus cosine alpha times sine beta. So the difference between the two of them is, if you notice, sine keeps the same sign. So if you have minus here, you're going to have minus in the equation. If you have plus here, you're going to have plus in the equation. Now for cosine, you have the opposite. So if you have minus, you're going to have plus in the equation. And if you have plus, you're going to have minus in the equation. So if you're calculating cosine in the homework, you're going to have to make sure to change the sign based on what is written in the initial. And if you're going to do the opposite, so if you say you're given the formula, you want to be able to find the opposite of that. So make sure you change the sign. So that's the difference between the two of them. So let's do a couple problems like this. Let's try a couple examples of this. Let's make the first one the sine of 75. This is when I would think of two angles that add up to 75. The ones that I think of right away are the sine of 45 plus 30. And then I look at, okay, do I have sine or cosine? I have sine, so that means I'm going to use these two right here, and the sign will stay the same. So if I have positive, my full equation is going to be positive. So it'll be the sine of alpha plus beta. And then I label my alpha and my beta. So my alpha will be the 45 degrees, my beta will be 30 degrees. So we'll do sine of 45 degrees times the cosine of 30 degrees plus the cosine of 45 degrees plus the sine of 30 degrees. And then this is where you would use your chart to find out what the sine of 45 is and the cosine of 45 is, and the sine of 30 and the cosine of 30 is. We know that the sine of 45 is the square root of 2 over 2. The cosine of 30 is square root 3 over 2. The cosine of 45 is also the same as sine of 45, which is square root 2 over 2. And, oh, I made a mistake. Remember, this is multiplication, not addition. So Make sure that we have the multiplication between them. And we get 1/2 for the sine of 30. Now, you can just do the basic math, and what will happen is when you multiply these two together, you get square root 6 over 4 plus the square root of 2 over 4, which will then give you square root 6 plus the square root of 2 over 4. And I'm going to do this on my calculator, so I'll go through each of the steps. The square root of 2 over 2 times the square root of 3 over 2 is going to be the square root of 6 over 4. Yeah. So go back and check to make sure that your solution is correct. Now, let's do another example. And I'm going to let you try this on your own. So let's try the cosine of 15 degrees. So go ahead and pause the video and try it on your own. Okay, welcome back. The cosine of 15, the two numbers that I used, you can also use other ones. I used 45 minus 30. But it's going to be a little bit different because cosine is different than sine. So if I have cosine 45 minus 30, if I have alpha minus beta, what's going to happen is I'm going to have, instead of subtraction, I'll have addition. So it's going to be cosine alpha. So cosine of alpha minus beta gives me cosine alpha times cosine beta plus the sine alpha times the sine beta. If you still notice the cosine is the same so the cosine and cosine is together and the sine is together in cosine, but if in sine it's alternating. You have sine, cosine, cosine, sine. It's a little bit different. Alright, now we just put what goes where. This is our alpha and this is our beta. Cosine of 45 times the cosine of beta plus the sine, that's the cosine of 30. The sine of 45 times the sine of beta, which is 30. Okay, cosine of 45 we know is square root 2 over 2. The cosine of 30 is square root 3 over 2. The sine of 45 is square root 2 over 2. And the sine of 30. And if you did not have your chart, you can always put it in your calculator to confirm what it is. So if you were to put the cosine of 30 in your calculator, you would get the square root 3 over 2. Then when I multiply these two together, I get square root 6 over 4 again, and then I will get square root 2 over 4. And if you notice, we get the same answer. As the last one. But what if I have an angle that is bigger than these two, for example? Because if we're in let's say we're in the third quadrant, we're going to have a change in sign. So I want you to try this example and see if you can get the answer. Let's do the cosine of 255 degrees. Okay, welcome back. So I chose, for the cosine of 255, I chose to do cosine of 180 degrees plus 75 degrees. So if I have plus for cosine, that means it's going to be minus. So it'll be cosine alpha times cosine beta minus sine alpha times sine beta. Then we put our allotted numbers. So cosine of 180, this is alpha, this is beta, times cosine of 75 minus sine of 180 times sine of 75. And this kind of goes back to doing reference angles. So whatever quadrant we're in, we're going to calculate based on that. We know that 75 is going to be in quadrant 1, right? Because this is 0, 90, 180, and 270. 75 is going to be here. So we know that sine is definitely going to be positive. And cosine will be positive for the 75 degrees. But 180, if we have 180, this guy here, we have to figure out what the reference angle of that is. So if I were to find the reference angle, I can actually put this in my calculator right away. Cosine of 180, we know, is -1. So that means the cosine of 180 is -1. But what about sine of 180? So if I put my calculator, sine of 180 gives me 0. So we know 180 is going to be 0. And then cosine of 75, we can leave that the way it is, or we can do exactly what we just did. Cosine of 75 is the square root 6 minus the square root 2 over 4. What about the sine of 75? Sine of 75 gives me square root 6 plus square root 2 over 4. So all in doubt, you can use your calculator to find these if you're struggling to find it, but there's a way to find it without using your calculator. Let's show that. So back in 6.4, we went over what the x and y values would be depending on the quadrant you're in. In quadrant 1, theta will be an x comma y of 1, 0. If you're in quadrant 2, the theta will be an xy of 0, comma 1. If we're in quadrant 3, we would be an xy of -1, 0. And then if we're in quadrant 4, we would be 0, comma, -1. So that's why 180 here, the x value is -1. And in quadrant 1, the value would be 0. So the reason why the cosine is -1 is because it lies on the x coordinate. But the sine is 0 because it lies on the y coordinate. That's how we tell the difference between the two of them. If we were to draw a triangle there, it would also show us that. So this is why the cosine of 180 is -1 and the sine of 180 is 0. When we do the multiplication in the second part here, what happens is anytime you multiply something by 0, it becomes 0. So really we're going to be multiplying the first one, and what happens is it will just become negative square root 6 times square root 2, or minus square root 2 over 4. And then if you wanted to separate that out, you could write this as negative square root 6 over 4 plus square root 2 over 4. But both are correct. So whichever you get here is correct. Okay, let's do another one. Let's try... Let's give an example if they were to give us tangent. If they gave us tangent, let's try tangent A minus B. So let's do the tangent of 285. We're going to use this as an example, just in case the homework gives it to you. So if I do a minus b, the tangent of a minus b, this would be 360 degrees minus 75 degrees. If I was to set it up, remember when we had previously, we were doing reciprocal identities. Let's use that identity was sine over cosine. But for tangent, we're going to be doing something a little bit different in regards to these problems. So how we're going to set this up is it's going to be tangent of A, or alpha, minus the tangent of B divided by 1 plus tangent A times tangent of 70, or whatever our B is. So that'd be a 75. So now we can calculate this. So tangent of 360, which is A, this is B. 360 minus tangent 75 over 1 plus tangent of 360 times tangent of 75. So let's figure that out. The tangent of 360 is 0. Tangent of 75 is square root 6 plus square root 2 over 4 divided by 1 plus the tangent of 360 is 0 times, again, square root 6 plus square root 2 over 4. And then when I do the math, what's going to happen is I'm going to get negative square root 6 plus square root 2 over 4. And you're going to have your calculator again, so you'll be able to do all of this in your calculator. Just make sure that you don't make an error while doing it. Most often, I showed an example like this one because in your homework, you might have one where it asks you to calculate tangent. But what if it was the tangent of alpha plus beta? If it was alpha plus beta, let's show an example of that. So let's try the tangent of 75, for example. So if it's a tangent of 75, let's do one where it's alpha plus beta. So let's, or A plus B. If I did the tangent of 75, let's do, it's 45 degrees plus, is it, 30 degrees. That'll give me 75. So if it's positive, then I would write it like this. The tangent of A plus the tangent of B over 1 minus the tangent of 45 times the tangent of 30. Then you would calculate it like we just did in the previous as well. A and B. I put the values in. Tangent of 45 plus the tangent of 30 over 1 minus tangent 45 times tangent of 30. Well, we already know what these values are on our chart. So tangent of 45 we know is 1. What about the tangent of 30? The tangent of 30 is square root 3 over 3 over 1 minus 1 times square root 3 over 3. Now, if I do this on my calculator, let's see what I get. So if I put this in my calculator, what I get is 1 plus the square root of 3 over 3 gives me 3 plus the square root of 3 over 3. And same thing on the bottom, 1 minus 1 times square root of 3 over 3 gives me 3 minus square root of 3 over 3. And I will get 2 plus the square root of 3. If you did this a little bit different, that's okay. There's many ways to do this. Okay. The key takeaways to solving these problems, though, is to make sure, and most often you're going to be given cosine or sine, especially on the exam, they're not going to give you tangent. You need to use these 4 formulas, and most often what will be given is the actual formula to use, so you're just going to plug whatever you get for those values in the previous problem, and then put them into the formula, and then solve. You shouldn't have to be able to change the signs. But if when you're doing the homework, you're going to have to change those signs and make sure they're proper. If they're not, you're going to get the wrong answer. Now let's do some examples where they give you the formula, but they don't give you the actual beginning part. So what do I mean by this? So let's do an example. They give us a sine of 50 degrees times the cosine of 40 degrees plus the cosine of 75. No, actually, that's 50. 50 degrees times sine of 40 degrees. If they give us this formation, they want us to condense it into the correct form. Either it's sine or cosine, plus or minus alpha and beta. I see that we have alternating sine and cosine. So right away, I know this is going to be sine. It's going to be sine. And then if I have positive, if it's positive, that's what's written here, then it'll be positive written here. So if I have positive, it'll be 50. So it'll be sine of A plus B, or alpha plus beta. Either one will work. So this means what I'm going to write is it's going to be sine of 50 degrees plus 40 degrees. And if I write that again, sine of 90 degrees, we have to figure out what is our value. Well, sine of 90, if I look at that little chart we just made previously, sine of 90, we know is going to be, okay, that's more towards the middle of quadrant 2 and 3. So the sine of 90 is going to be just 1. And if I was to put that on my calculator too, we'd get the same exact thing. 1. So if you can write what your x and y values are in each of the quadrants, that will actually really help you. All right, let's do another example like this. Let's do the cosine of 120 degrees times the cosine of 30 degrees plus sine of 120 degrees times the sine of 30 degrees. Okay, cosine and sine are not alternating this time, and I have a positive sign. So if it's not alternating, I already know it's cosine. But I have to figure out, okay, if I have positive in the formula, I have to have minus here. So alpha minus beta is going to be minus. So that means I'm going to have to write that this means that when we write it out, it'd be minus. So cosine of 120 degrees minus 30 degrees. So 120 minus 30 degrees is, let's see, 120 minus 30 gives me 90. And 90 degrees for cosine, if I look at cosine 90 degrees, I know that this is going to be 0. And remember that cosine is based on the x coordinate and sine is based on the y coordinate. So that's why cosine 90 is 0. And because we know that 90 degrees, we know the point is x value of 0 and a y value of 1. And cosine is based on the x. So this is important to know what the values are based on 180, 90, 0, and 270 as well. Let's try one that's a little bit different. Let's try cosine of 4x times cosine of 3x minus sine of 4x times sine of 3x. All right. I have cosine, cosine, sine, sine. I know this is going to be cosine because the cosine and the sines are together. We have minus, so that means alpha plus beta is going to be a positive result. That means it's going to be cosine of 4x plus 3x, which gives us 7x. Those are pretty simple. So this is how you solve equations for 7.2. Actually, let's do one more example. This one would be closer to what your exam will be like. And let's say they give you a quadrant and they give you a sine or cosine. So let's do this example. This is more similar to exam. So they give us sine A of 8 over 17 in quadrant 2, and then they give us cosine B of 3 over 5 in quadrant 4. And then they'll ask us to find, let's try A of sine A minus B, and then they ask us to find cosine of A plus B. So I usually do each side separately. So what I'll do is I'll do in quadrant 2. So I'll draw it out for myself. So in quadrant 2, it'll be here. So this is my X, Y, and R. And the other one is in quadrant 3, or no, quadrant 4. So that means my triangle will be drawn here. Y, X, R. And then I'll label a ASTC. And remember, ASTC means that all of them are positive in quadrant 1, sine is only positive in quadrant 2, tangent is only positive in quadrant 3, and cosine is only positive in quadrant 4. So we're 3, 2, 1. Sine is y over r. So if they give me my y is going to be 8 and my r is going to be 17. So then what I need to do is calculate via the Pythagorean theorem. You could also use the other identity that we used before, was sine plus cosine equals 1, whereas it's sine squared plus cosine squared equals 1. But I find that this identity or this formula is a lot easier to solve. Again, my x is what we're looking for, my y is 8, and my r is 17. So 8 squared gives me 64. 17 squared gives me 289. Then I want to get x squared by itself, so then what will happen is 289 minus 64. And I get 225. And then I can take the square root. And I get 15. So x equals 15. So my x is 15, my y is 8, and my r is 17. So now I can find, if they're asking us to find So we have sine A, we need to find cosine B. So cosine A. So cosine is x over r, x is 15, and my r is 17. But am I done? No. What I need to do is I need to make sure my sine is correct. In quadrant 2, sine is positive, so 18 over 17 is correct, it's positive. But in quadrant 2, my cosine is going to be negative, so it'd be negative 15 over 17. So I have my cosine A, my sine A. So most often in the exam, what they'll say is find sine A, sine B, and cosine B. And then you'll use those to solve for your equations up here. Or they'll ask you in 7.3 to solve using the equations from that. So we're going to do that, another example like this at the end of the next video. All right, using cosine B, I need to find sine B. So I have x over r. This means I have my x and my r, but I don't have my y this time. So my x is 3, my r is 5, and I need to find y. So x squared plus y squared equals r squared, x squared, 3 squared, and r is 5 squared. So 3 squared is 9, 25. So get y by itself, so you do 25 minus 9. So 25 minus 9 is what? 16. Take the square root. Y equals 4. So we have our y, our x is 3, and our r is 5. Now I can find my sine B, which is y over r. Y is 4, and r is 5. Then again, I look at my quadrant. So again, cosine is positive in quadrant 4, so that one's good. And then we find sine B. So sine B in quadrant 4 is going to be negative, so that means sine B is negative 4 over 5. Now I have all my pieces, then I can solve for sine A minus B and cosine A plus B. So let's do the first one. Sine A minus B. If I go back to my original 4 equations, let's see. So sine A minus B is sine alpha cosine beta minus cosine alpha times sine beta, or you can write this as A, B, A, B. So my sine A was given to us, so that's 18 over 17, or 8 over 17, times cosine B. Cosine B was given to us, 3 over 5, minus cosine A is negative 15 over 17, and sine B is negative 4 over 5. And then what I do is on my calculator, I can just multiply these together. 18 over 17 times 3 over 5 is 24 over 85. And then negative 15 over 17 times negative 4 over 5. And remember, when you have two negatives, they multiply to each other, they become positive. So what happens is when we calculate this, we get what? Let's see. I get negative 36 over 85. Now, you could have changed this to the same denominator, and you could change this to 60 over 85. But if you left it like this and subtracted, you would still get the same exact answer. Now let's try doing the opposite of that. So let's do cosine of A plus B. Cosine of A plus b. So if I have plus, I have to make sure to change the sign, but they'll give you this, they'll have this written for you all the way out. Cosine alpha times cosine of beta times sine beta. Now, my cosine A, again, was negative 15 over 17. My cosine B was 3 over 5. And my sine A was 8 over 17. And my sine B was negative 4 over 5. So now I can multiply these. So 15 over 17 times 3 over 5. I get negative 19 over 7. And then I get 8 over 17 times negative 4 over 5. Negative 32 over 85. So when I do the subtraction, what's going to happen is I'm going to get, let's see, I get negative 13 over 85. And again, you could have changed the front one to be the same denominator as the 85. So this is how you solve for problems like this. And then I will show you in the next video the final step if they were to ask you to solve using the formulas for 3.7 or 7.3.